Okay, in this video today, we have a voltage controlled amplifier. And I've got a bunch of generators hooked up, and I'll kind of explain to you later on. I'll rip it apart. But we have this simulator is called falstad, and it's free. You can use it online or download it. You can also add this audio output feature, and then you can actually you'll this waveform, we'll actually be able to hear it. I'm going to play it to you now. Hopefully it'll work. Okay, it almost sounds like a train, right? Kind of neat. And how I did that was combining 400 hertz with 500 hertz, and I'm modulating it so this is just like controlling this signal here controls the amplitude of this amplifier. So the amplitude is going up and down, or in other words, the gain of the amplifier is going up and down at a 60 hertz rate. And I can vary all these. And I found out I needed a DC offset mixed with the 60 hertz so it properly works. I'm going to show you how the DC model works first, and then you kind of understand in a second how everything else works. So I'm going to remove all these input generators because they're just signal sources, right? And now we'll just have 5 volts coming into our circuit. And I want to look at the output. Okay, the output with 5 volts coming in is zero, almost 0 picovolts, so it's very low. That's what we want. Now, obviously, I could put an input signal here, and then we would get something different, right? So let's say if I had a DC signal, let me get a DC signal. DC, I don't want AC, add a voltage source. Yeah, this is right. And it's like this. Let's go like this here. And I'm going to move it in here and connect it to the input. So now I've got DC, but this is too high. Okay. I am going to put it about 1 volt. Now, the way I've calibrated my amp is like this voltage here is going to control the gain. So the way I've calibrated this amp, this 5 will represent, it'll tell this amplifier to, like it'll control it in such a way that the gain of this amp will be 5. So 5, and then we have a 1 volt input. We should get 5 on the output here. And do we do? Oh, we get 5.111. So I guess we're good. There's always a little error, right? And so that nice thing about the way I've done this, if you watch this graph, it's showing 5.111. If I go to 10 volts, so I've set it so we have a 0 to 10 volt input. Will give you 0 gain up to a gain of 10. So let's put this at 10 and see what happens. And there we go. You see it's come up to 10.11. Nice and linear. And let's say I want a gain of only half. Okay, so it should actually divide our input down. So we've got 1 volt times a gain of half should give us half out. Yeah, and that's exactly what we get. So, and it works with negative DCs as well. If I put negative, let's see, 5 volts in there, okay, you get negative 2.5, and it looks like that's what we're getting at, negative 2.57. So nice. So that's how this works. And the way the amp works is this voltage is going through this circuit here. Okay, this circuit here. Okay, I'm just trying to kind of outline it with my mouse. Okay, this circuit here is what they call a voltage to current converter, and it's a linear. So there are simpler ones, but this one's linear. So if I double the voltage, my current should double, or if I half, it should half. And the current I'm measuring is this current here. So what this does is this controls, it's this resistor that sets the current, and then the current is constant through this line here. And this is a mirror circuit, so whatever comes down here is going up as well, right? It's like they're both sides of the same current, and so let's look at this current. It's 5.8, and if I go to 1 volt, it should double. So that would be, maybe like 10, 11.6. Yeah, that's double. Can't do my math. But you see what's happened there. When this current doubles, the gain of this amplifier doubles. So that's how this amplifier works, right? And then the output is taken here. So it's a differential amplifier. Okay, so that's sort of what I wanted to describe how it works. And then of course, you can use AC signals. I showed you with DC, and we can also use it with AC signals. A lot of musicians use this to maybe their music is coming in here, like we did this, or like you might have guitar or something, or maybe from a synthesizer coming in here, and you want to change the sound of it. You can add some kind of strange wave shape. Well, this is just a sine wave, but you can add any kind of wave shape, and it'll change the amplifier gain according to this wave shape, but it'll be passing to the sound. Not only that, you could actually mix two frequencies in, just like I did before when I created the train sound. Now you can see the wave shape for this sound. I kind of think it sounds like a train. The reason it's kind of missing the gaps, you need that DC offset, and you can work out all the math on that if you want, but it needs a certain amount of DC so it doesn't hit the zero line like that. So I'll just edit this. What I found is you need around 5, and then you can mix the AC here, and the DC is mixing into this terminal, and you see it's a lot nicer now, right? And so you can play around with these values and get all kinds of different effects. So I hope this video has been helpful for someone who maybe is interested in learning how to build an amplifier, like a voltage controlled amplifier. And so go ahead and try to build it. I have never tried to build it. I think the simulator is using, perfectly matched transistors. So, I haven't tried it to see how well it works. You can buy matched transistors. That might be the best way to go. These ones might be less critical, but it might be a good starting point to get matched ones if you're not sure. Or just pay attention to the current right here and see if it's linear when you come in, because that's the main thing, is if it's linear, if you double the voltage, that this doubles. If you can get that effect, then you could probably calibrate it by just changing some resistors here in the gain. So this probably is not as critical as these two up here, or these 4, 1, 2, 3, 4 transistors. This is just a garden variety op amp. Probably any TLO 72, I think, is what I would probably recommend, but you can try a lot of different ones, I suppose. And we have it plus 15 and minus 15. That's probably a good starting point. You can probably adjust these and make them lower if you play around. I would try the simulator, on the free one, falstad simulator, and then you can mess around with the values and try to build it. Anyway, if anyone does build it, let me know. I don't have any parts. I'm sort of living out of a suitcase, so I wish I could build it and test it, because I was looking forward to doing that. But on the simulator, it seems to work really well. Like the range is really linear all the way through from 0 to 10 volts. So the gain of the amp is really nice. But that's if maybe the parts have to be, I don't know how accurate they have to be, but it'd be interesting to give me some feedback on that if anyone gets a chance to build it. I think these are just 2N3904s and 3906s in the simulator, but the simulator uses perfectly matched ones, right? So whether it'll work, you might want to try to balance them out, or maybe it'll work just like that, with just a random pile of transistors. But I think the more accurate they're balanced, it's probably going to give you better results. Anyway, I would love to see if anyone actually builds this thing and gives me some results from their testing. Thank you very much for watching. Have a great day.